Hello, welcome. My name is Jan and I would like to introduce you to features extraction. Let's start with overview. Feature extraction generally means generating new features from existing dataset we have. And we can look at different type of feature extraction based on type of data we have. We can extract data from images, from tabular data, from text. Also, we can think about audio files, video, but this is not part of this micro lecture. So let's start with feature extraction from images. And here we will talk about two different methods. We will talk about a traditional machine learning, and in traditional machine learning we extract specific image properties that can help us with better classification, object detection and facial recognition. But also we have deep learning, where we have convolutional neural networks that automatically extract features from the data. Basic image features. First image feature we can think about is color feature. In the image below, we can see on the left side beautiful painting, and on the right side we can see distribution and proportion of individual colors represented in this image. And we can use this information about colors and proportion as another feature for modeling. And it is already giving us insight and understanding about nature of the image. Another color feature we can observe is intensity, which is giving us information and insight about brightness or intensity of individual pixels. For example, in the image below, we can see distribution of number of pixels based on brightness. And from this we can see we have main concentration of pixels between 200 and 250, which is very close to white color. If we expand to colored image, we can observe histograms of different color distribution within those images. For example, in the image below, we can observe very high intensity values of blue color, but on the other hand, low intensity of the red color. And this information about distribution of different colors is another feature we can use in modeling. Another type of features we can collect from images are texture features. Those features are telling us information about variation of intensity and colors in images and about spatial arrangements of pixels within image. One example of the tool we can use is co-occurrence matrix, that is calculating number of pairs of pixels with specific intensities next to each other. The example of the right is highlighting calculations of pairs of 1 and 0, and we can see we have two pairs of pixels, 1 and 0, in this image. And finally, we can cover specific metrics that can help us to understand image, which can be, for example, contrast, that measure differences in intensity, or for example, energy and entropy, that give us information about uniformity or randomness of the texture on the image. Another family of techniques we will cover is filtering, that help us to reduce noise and detect features in images. First and computationally simple method is mean filter, that is reducing noise by calculating mean of neighboring pixels. This can help us to reduce noise, but on the other hand it can a little bit blur edges. Median filter is better in keeping edges of objects, and we can see example of median filter on the right, where we have noisy image, but after applying median filter we were able to keep the edges of objects but still reduce the noise. Another filter we will cover is Gaussian filter. This type of filter is not good for keeping edges, but is more used for blurring the image. It's using behind Gaussian filter, that is putting more weight into center of kernel and lower weight to the edges, which produce smooth blurred image, as we can see in the example in bottom right, where we have on the left original image and blurred image on the right after applying Gaussian filter. From filtering, we can move to edge detection, which is a very useful method to identify, based on change of brightness, silhouette of the image. The most important method in here is scanning edge detection. That is multi-stage method that is very accurate in detecting edges. We can see in bottom example of the football player with the ball, and this method is very good in capturing edge or silhouette of the body of the football player as well as the ball. In this type, we will cover another two edge detection filters. First of those is Sobel filter that calculate first order derivative, therefore difference between neighboring pixels. And what is important, this filter is directional. Therefore, we need to decide whether we want to apply this filter horizontally or vertically. Another filter is called Laplacian filter, which calculates second order derivative, therefore differences of differences. And this filter is non-directional. Therefore, it calculates edges in all directions. And we can see example on the picture on the right. In bottom left, we have an original picture of Sudoku game. And if we look in the bottom, we have firstly vertical and then horizontal Sobel filters that detect specific edges. And then in the end, we have on the top right Laplacian filter that is able to detect edges in all directions. Now we can move to deep learning, where we have famous concept of convolutional neural networks. It uses mathematical function convolution that is used to combine two different functions. In this case, we combine data from image section, data about pixels intensity, and weights from the kernel. After performing multiplications on the image section with kernel, we save single value to the output layer. This kernel has specific parameters, which is stride, that is telling us how many pixels we move in each step. We have different kernel sizes. Usually it's square. It can be 3 times 3, 5 by 5. Also, if we have image with different channels, we may apply multiple filters to capture different parts of the image. And finally, this kernel has weights that are learned during the model training. In Python, we have very good availability of modules for computer vision and image processing. The leading module for traditional computer vision is OpenCV, that includes many methods for edge detection, face recognition, and so on. We can follow with PyTorch, which is the most popular package for deep learning, that includes methods like convolutional neural network, transformers, and so on. And finally, we have two scientific Python packages, scikit-image and scipy, that can allow us to apply many filtering and transformation methods on images. Now let's move to feature extraction from tabular data. We can talk about extracting statistical feature, about aggregating data, and dimensionality reduction. So if we talk about statistical feature, we can calculate statistical features like minimum, maximum, average, median. Also, we can calculate standard deviation, variance, and also we can calculate correlation between different pairs of features, which we can also visualize in a correlation heat map, as we can see on the right side of the picture, which can give us some insights about features and relationship between those. Sometimes we might have data set with a huge amount of features, for example hundreds or even thousands of features. And for machine learning algorithms, it's difficult to process effectively this size of data set. Therefore, we might apply so-called dimensionality reduction that can help us to extract the most important component from this data. And the key method is PCA, called principal component analysis. On the picture on the right, we can see example of two components. First component is on x-axis and second component on the y-axis. And we can see that based on those two components, we can separate data into clusters, which can be very useful for classification modeling. Finally, we can move to text data. Most of the time, machine learning algorithms cannot process text data directly, but we need to convert text data into numerical values. The simplest approach is to take, for example, sentence, paragraph, or some bigger section of text and calculate the frequency of each word in this text, number of the occurrence of each word. Another option is to look at the back of n-grams, which is combination of two words or three words. For example, we can calculate how many times we can see in the text combination this is, or for example, he has, or for example, get is. If we talk about more advanced techniques, we have a method called TF-IDF that calculate frequency of words in document. We can also use word embedding that captures semantic meaning of words and transfer into vectors. And finally, nowadays very popular transformers GPT models that have capabilities to understand meaning, contextual meaning from the text and extract understanding and relationships. That's all. Thank you for the attention and see you in practice session.